I'm going to work out a sample heating curve problem for you just to help you work through some of the problems in your homework. And if you saw the first effort I made at this, there was an error in it, and so this is a corrected version. All right, so let's read the question. Okay, we have 150 grams of water, H2O, and the temperature is originally at minus 18. Okay, we know the melting point or freezing point, same thing, for water is 0 degrees, and that the boiling point is 100 degrees. All right, so we're starting at negative 18 degrees and raising the temperature, letting it completely melt, and then raising the temperature again up to 25 degrees. And it wants to know how much energy is required to do this whole thing. And so probably the most important thing to know about a heating curve is that every single segment is a separate calculation. So that's calculation 1. Melting is calculation 2. And heating up the liquid water is calculation 3. All right, so if it's a sloped area like calculation 1, you use QMCAT. And so I'm going to plug in the values. And the mass is 150 grams. Specific heat capacity of ice. Make sure you get the right phase of matter. Nope. Let's see. Here we go. Solid. Okay, so the specific heat capacity of H2O in its solid form, 2.09. Notice that is joules, because not all of them are. And change in temperatures, final temperature minus original temperature. This is where I made the error on the last attempt. The final temperature is 0 degrees minus the original temp, which is minus 18 degrees. Alrighty, so if we go ahead and punch that into our calculator, which I'm doing now, let's see, 18 times 2.09 times 150. The heat thermal energy is 5,643 joules. Alrighty, step 2, calculation 2, and that is to melt the entire substance. There's no temperature change, so we have to use the formula Q equals quantity. So really that M could be mass or moles depending on the units of the delta H. And this is melting, which we call fusion. All right, so plugging in the values. If you look at heat of fusion for water, it is in kilojoules per mole. So this quantity has to be moles. So let's see, we have 150 grams of water. In order to get to moles, we divide by the molar mass of water, which is 18.02 grams per mole. And then delta H of fusion is 6.01 kilojoules. So let's see, 150 divided by 18.02. So it's 8.32 moles, and then multiply that by 6.01. So now that is 50.03 kilojoules. Okay, so before we add all these together, we're going to have to make sure the units match. Calculation number 3, which is raising the temperature again from D to E, that segment. It's QMCAT. So mass hasn't changed. It's still 150 grams. Specific heat capacity for liquid water, we're in the liquid phase now, is 4.184. And the temperature change, let's see, final temperature for this segment is 25. Initial temperature for this segment is 0. That makes our life easy. And plugging those values into the calculator, 150 times 4.184 times 25. And that is 15,679 joules. Okie doke. So the total heat, the total thermal energy for that entire process, we add them all together, but they have to be in the same units. The problem asked us to put the answer in kilojoules, so I'm going to change the one in joules to kilojoules. So the conversion factor between joules to kilojoules, there is 1 kilojoule per 1,000 joules. Okay, so it's the same thing as dividing by 1,000. So 5.643 kilojoules. It really didn't take very much energy to heat up ice to the melting point, did it? All right, so the energy required to melt is already in kilojoules. It's about 10 times more than raising the temperature. And then the energy required to raise the liquid water by 25 degrees is in joules. So I'm going to divide that by 1,000. And that ends up being 15 point, I'm going to round it, 70 kilojoules. So then if we add all those together, let's see, 5.643 plus 50 plus 15.7. And that equals 71.4 kilojoules. Alrighty. Hopefully that's helpful. I hope you practice a bunch of these. And I will see y'all next week.